All right, so first of all, today you guys are going to talk about simplifying square roots. So when I start this lesson, the first thing I want to do is this, the square root of 20. Okay, I just want you to watch on the calculator. So to use my calculator, if I go to square root of 20, I get an answer of about 4.4721359555. This is a number, boys, you listening? This is a number like pi. It's an irrational number, okay? As an irrational number, this number never ends. This is not the exact answer. It's not. So in order to keep it exact, what we're going to do is keep it in square root form. However, within these square roots are perfect squares. So what are the perfect squares? Let's write those down first. You know those numbers, but let's write them down anyway. So perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and we'll go to 169, okay? These are what we call perfect squares, because all of these numbers have a square root. Square root of 4 is 3. Square root of 9 is 3. Square root of 16 is 4. Square root of 25 is 5. 6, 7, 8, 9, 10, 11, 12, and square root of 13 is 13, okay? These are called the perfect squares. So within these numbers are perfect squares. So number 1 is a great example, because I'll say, okay, what times what makes 20? 5 and 4. We don't want to use 2. There you go, good. We do not want to use 2 and 10, because there's no square root of 2. There's no square root of 10. You want to find one of these. So Landon's right. We're going to rewrite this as the square root of 4 times the square root of 5, because there is a perfect square root of 4. Don't use 2 and 10. Don't use 2 and 10. There is not a perfect square root of 2, and there's not a perfect square of 10. So the square root of 4 we can do, 2, the square root of 5. So what we've done is, in a sense, like fractions. We've reduced the square root. These two have the same value, but this is a reduced version of this. Okay. Number 2, the 3 is on the outside. It's a regular whole number 3, so we're going to leave it alone. But let's take a look at the 18. What times what makes 18?
4 and 9.
2 and 9, but so we'll go square root of 9, square root of 2, right? I like to write the perfect square first. You don't have to, but I like to, because it's the first thing I want to take care of. Square root of 9 is a 3. And I am multiplying, so 3 times 3 is 9, so I get an answer of 9 square roots of 2. So what I did is I left the whole number on the outside. I found two numbers that made 18 when I multiply. One of them had to be a perfect square, which is 9. Square root of that 9 is 3. 3 times the 3 on the outside made the 9, square root of 2. Pretty easy so far? Okay. Now, 3. Before I start 3, let me do a little side work up here. This x to the third times x to the third is x to the sixth. So when I take the square root of x to the sixth, I'm just going to go to x to the third. Does that make sense? If x third makes x sixth. Or another way to look at this is x third squared. So sure enough, the square root of this would be x3. Another way to do this on x1 is just take half. Take half the x1. Let me get my red pen, okay? So another way to do it is to take half the exponent, okay? So when I do this, 48. Now what times what makes 48? Well, 4 and 12, and 4 and 12 will work. But I like 16 and 3 better. 4 and 12 will work. And I'll show you real quickly 4 and 12. 4 and 12 work if you went 4 and 12, right? Then you can break down 12 further, right? 4, and then 12 can be 4 and 3. And this is not wrong. Square root of 4 is 2. Square root of 4 is 2, right? But I like to do this a little bit faster. So by the way, 4 and 12 will work, but then you got to break down the 12. It's more work. I like to take and use 48. I like 16 times 3. It's a faster way, right? It's a faster way. The analogy I like to give is this. Let me show you. If you had 4 eighths, you could go 2 fourths, and you can go 1/2, right? You could, right? Square roots are the same way. I could go 4 and 12, and then break down 12. I'm just going to, though, go straight to square root of 16 times the square root of 3. Okay. Square root of 16 is a perfect square. Square root of 16 is a 4.
Wait, it's still x to the 6?
Yeah, I'm going to do that real quick. I'm going to change it real quick. I'm doing it step by step. So I'm going to take half of this right now. So when I take half of it, becomes x3, right? And when I take the half, I'm taking the square root, so it comes out. Does that make sense? When I take the square root of 16, it becomes 4, it comes out. Don't take the square root of that. It's out. Don't take the square root of 4, it's out. Don't take the square root of 4, it's out, it's done.
What happened to the 3?
Well, we got to put that there, don't we? So the square root of 3 is left over, right? Okay, we did this last year, didn't we? A little bit. Yeah. Okay. You might not have. If you didn't have me, you might not have done this. Okay. Okay, slide it up. Oh, how am I doing so far? Pretty good?
Yeah.
Okay, this should be easy. Okay, number 4. So these are regular whole numbers. Let's multiply them first. Let's get 6, and then these two square root numbers will multiply. We get the square root of 18, okay? Now, we would be done if 18 wasn't reducible, but 18 is reducible. So what times what makes 18? 9 and 2, yeah. So we're going to go keep the 6, square root of 9, square root of 2, right? Makes a 6, square root of 9 is 3. Okay, and the square root of 2 we don't know. It's just some really ugly decimal number, so we keep it as square root of 2. 6 times 3 is 18, square root of 2. Here it is. Okay, remember this from last year?
Yeah.
Okay. Now, 5's a little bit harder, but I'm pretty sure we can do it. So first of all, 5, keep the 3x out. It's out. It's not in the square root. But we're going to break up 50. Yeah.
5 and 10?
25 and 2.
25 and 2, right? Why 25 and 2?
Because 25 is perfect square.
There you go. Now, this is not even. So what I'm going to do is take 1 away from it. Take 1 away from it to make the biggest even number I can. I'm going to take 1 away, just 1 away. So I'm going to rewrite this as x to the 6 and x to the 1. I don't need the 1, but I'll put it there anyway. So I take 1 away to make it the biggest even number I can. Because remember, we said up here, we're going to take half of it. So to take half of it, I had to make it an even exponent. Okay, so now let's see what I have. Got a 3x. I have a 5. I'm going to take half of this, right? Take half. I'm going to take half of that and make that x to the 3. And then the square root of 2 cannot reduce. And the square root of x cannot reduce, so they stay inside. We'll put them together, okay? So the 2 and the x can't be done, so we left them inside the square root.
Where did the 1 go?
What one?
Yeah, x.
Oh, x to the 1? Oh, you don't really need it. Well, how about right there? You don't need it, because x and x to the 1 same thing. Aren't they? And now, finish it up. I've got a 15, x to the 4th, square root of 2x.
Wait, hold on.
Okay, I will.
Wait, why x to the 4?
Great question. How many x's are right here? How many x's are here?
Uno.
Plus how many there? Okay. All right, number 6. We're just going to multiply, okay? We're going to get a 8. Regular numbers with regular numbers. Square root of square root numbers with square root numbers. I get a 9x squared, okay? Multiply regular numbers, whole numbers with whole numbers. Square root numbers, square root numbers. So then, can we take the square root of 9? Sure we can. Square root of 9 is 3. I'll take half of this and make it x to the 1. Answer, 24x. Or x to the 1. If you want to put the 1 in there, that's fine. How am I doing? Okay?
Yeah.
Even if you've never seen this before, does it make a little bit of sense? Good. 7, super easy. It's just like our warm-up. Don't let it confuse you. If they're both square roots, it's the same thing as square root of 4 over the square root of 9. It really is. It's super easy. Don't overcomplicate this one. The answer is just 2/3, okay? All right, now, am I going okay?
Great.
I'll wait for you, okay? Yeah. I'll wait for you on 8. 8 we're going to distribute, but I'll wait till you're ready, okay? Okay, so on 8, we're going to distribute this times this and this times this, boys. Ibrahim, shh, Isaiah, shh, Isai, shh. Okay, I did. Okay, 6 square roots of 9. Do you see it? 6 square roots of 9. 2 times 3, 3 times 3. Plus 2 square roots of 3. Now this one's a little tricky, but you have to multiply whole numbers with whole numbers. So the 2 times the 1 makes the 2, and the square root of 3 just comes along. It's like multiplying with x's, okay? The 2 times the 1 makes the 2, and the square root of 3 comes along. Now, I can do a little bit more. I can take the square root of 6, can't I? So I can go, okay, 6 times 3 plus 2 square roots of 3. I got the 9 from the square root of 3 times square root of 3. And 6 times 3 is 18 plus 2 square roots of 3. Now, they're just like x's. If they're not the same, you cannot add them. So we're done. If they're not the same, you cannot add them. We're done. You can multiply things, but you can't add them unless they're the same. So we're done. Okay, don't add those two. Don't. Okay, 9, probably the hardest one, but we can do it. Actually, this one's not that bad. This one's actually not that hard because I gave you good, easy numbers. Okay, 4xy squared. Leave it on the outside, okay? 4xy squared. Just leave it out there, okay? Okay, is there a square root of 36?
Yep.
Yeah, plain old 6. What do you do with x to the 4th? Half it. x2, good job, Josiah. What about y to the 8th? Half it. y4. That's it. Now, is there anything left inside? No, square roots are gone. So let's tidy it up. 24. X and x squared makes x to the 3rd. Y squared y4 makes a y to the 6th. And we are finé with that. Finé. Thumbs up? Not too bad. Of course, if you had this last year, then it's probably pretty easy, right? Turn the page. Okay, number 10. So if they're the same, you can add them. So when you add them, though, listen. This is 2 square roots of 3 and 3 square roots of 3, so our answer should be 5 square roots of 3. How many square roots of 3's do I have? 5 square roots of 3, not square roots of 6. No, there's no square roots of 6. Do you see any square roots of 6 up there? No. It's just how many square roots of 3's do you have?
2.
That's it. Now, 11, you can't add them because they're not the same, but maybe we can reduce this and maybe this might work. So let's see what we can get. Okay, so I've got a 5 square root of 5 plus, what about 20? What are you going to make 20 into?
4 and 5.
Square root of 4, square root of 5, right? So I got 5 square roots of 5 plus 2. Okay, square root of 4 is what? Square root of 4 is what?
2.
Sure, plain old 2. Square roots of 5, okay? How am I doing, okay?
You're doing just fine.
All I did is I changed the 4 into a 2. Okay, now 2 times 2 is 4, right? You're way ahead of me, I like that. Yes. 5 square roots of 5 plus 4 square roots of 5. Josiah says that's 9 square roots of 5. I completely agree with you. Easy? Okay. All right. We're almost done. Almost done. Okay. All right, number 12. You can't add them because they're all different. But maybe we can do some and maybe we can't add them. So let's check. What do you know about 12? 4 and 3. You're way ahead of me. Who said that? Love it. What about this one? 9 and 3, yes. What about this one? Yep, 25 and 3, okay? So now maybe if I reduce them, I might be able to add some of these, right? Okay, square root of 4 is 2, right? Square root of 9 is 3. Square root of 25 is 5, okay? How am I doing, okay? I'm going to tidy it up and maybe I can add some things, right? Isabella has already got it done, but right? Ellie's got it done, but we'll get there, right? 6 square roots of 3, 12 square roots of 3, plus 10 square roots of 3, right?
That's 18.
28.
28.
I hear 28 squirts of 3s, not 6s. There's no stinking 6s up there, right?
How's it 28?
I get 18 plus 10.
Oh, I missed
That's all right.
it. Yeah, that's kind of right.
Now, 13 is a FOIL problem. So watch. I'll wait till everybody's ready, and we're going to do 13 together, okay? Here we go. We're going to go FOIL. Okay, we're going to go, you ready? 2 square roots of 3 times 4 square roots of 3 makes an 8 square roots of 9. I'm going to go slowly. 8 square roots of 9. Okay, I'm going to go slowly. And then I'm going to have a 2 square roots of 3 times a negative 1. Multiply whole numbers. So I'm going to get a negative 2 square roots of 3. You got to bring the square root of 3 along with it because you're multiplying 2 square roots of 3 times 1, right? Then 2 times 4 square roots of 3 makes a positive 8 square roots of 3. And then I've got a negative 2 times a negative 1 makes a negative 2. How am I doing? Okay. Now, there's some work to do, right? There's some tidying up to do. We can do that. This is obviously, the square root of 9 is obviously a 3, so I've got an 8 times a 3, right? These two middle terms are the same. They're the same. We can add those. Well, we'll subtract it, but we can combine them, right? So I'm going to get a positive 6 square roots of 3. Okay, so I can add or combine the middle terms, minus 2. How am I doing? Okay. Now, 8 times 3 is 24, right? Almost done. I just multiplied 8 times, that's all I did. And the final step, these are whole numbers, so subtract. 24 minus 2 is a 22, plus 6 square roots of 3. Don't add them. If they're not the same, you cannot add them. Okay. 14, you ready? Again, it's just another FOIL problem. It's a little bit bigger. So we're going to go, am I going too fast? So 5 square roots of 2 times 4 square roots of 2 makes a 20 square roots of 4. 5 square roots of 2 times negative 5. Multiply the whole numbers, so I get a negative 25 square root of 2. Multiply the inside. 3 times 4 square roots of 2. Multiply the integers plus 12 square roots of 2 and bring the square root along. And then finally, 3 times negative 5 is a negative 15. How am I doing? Okay. Now, these two are the same. We can add those. We can combine the middle two. But the square root of 4 is 2, right? So I get a 20 times a 2. These two would combine to a negative 13 square root of 2 minus 15, right? Almost done. 40 minus, wouldn't you know it, my pen's going to run out on me.
You want another one?
Well, I've probably got one around here. I do. Thank you for the offer, though. Really appreciate that. That's nice of you. So,
Red.
yeah.
I'm giving you a pink one.
Well, let's just finish with red, huh? Okay, now, put the integers together. 40 minus 15 is 25, right? So I'll have a 25 minus 13 square roots of 2. Okay, so real quick, before I stop, the moral of the story is this. Listen. You can multiply anything. I'll say it again. You can multiply anything. You just have to multiply, okay? But when you add or subtract, they have to be the same. When you add or subtract, they have to be the same. When you add or subtract, they are what they are saying. If the square root of 5 is the square root of 5. Does that make sense? Multiply or divide anything, add or subtract only the things that are the same. Okay, got a little assignment on the computer, and then with the last 10 minutes in class, maybe the last 15 minutes in class, I've got some art to show you.